The line y equals x plus c is the tangent to the graph of f of x is e to the x. We know that f dashed x is also e to the x here. We want to obtain the coordinates of the point of intersection of the tangent with the graph of f of x. Now there's only one place that this can be 1, which is the gradient we have here. And that's when x is equal to 0. So in other words, it's when x is 0 and e to the 0 is 1. So it'll be at 0, 1. So this graph, so if we think about this coming up here, and that's the point 0, 1, the tangent must touch here. In other words, the value of c is 1. So we're asked to sketch the graph of f of x and the tangent on the axes below. So we know what e to the x looks like. So it's going to go like this. And we know that's 0, 1. And so the tangent must go like this. Okay. Evaluate the exact area between the graph of f of x and the tangent line and the line x equals log 2. So if we say that this is where x equals ln 2, then we want the area in here. So that's going to be the area under the curve, take away the area under the line. So that would be the integral of e to x from 0 to ln 2. That's the area under the curve. So that's going to be e to the x from 0 to ln 2. E to the ln 2 is 2, e to the 0 is 1. So that area is just 1 square unit. Now, under the line, we know that the line is y equals x plus 1. So if x is ln 2 there, that point there is ln 2 plus 1. So the area under the line is a half times the base times the height. And so we have got that the area that we want is going to be 1, take away a half ln 2 plus 1. And square units. So that would be our answer, or something equivalent. And finally, it says, given that g of x is the inverse function of f of x, write a definite integral that could be used to determine the area between the graph of g of x, the x-axis, and the line x equals ln 2. So we know that f of x was e to the x. The inverse function of that, obviously, is the natural log. The natural log of 2 is less than 1. So what we're talking about here is the log coming up goes through 1. This is x equals ln 2. So we're after this area here. So if we did the integral of ln x from ln 2 to 1, that would give us an area, but it would be negative because it's below the axis. So if we just want to get the area, let's just put a negative in front.